All right. All right, well, in the interest of time, I think we'll go ahead and get started. Thank you all for joining us today for our webinar here at COP on AgMission. I'm Allison Thompson. I'm the AgMission Program Director at the Foundation for Food and Agricultural Research, or FAR, as we like to be called. The subject today will be our AgMission program, our efforts to cultivate climate-smart solutions. Before we begin, please keep in mind that the webinar is being recorded and all participants are currently muted. We will open the lines for Q&A. You can also use the chat and Q&A functions on the webinar to submit questions at any time. If you aren't familiar with FAR, we build public-private partnerships to fund audacious food and agricultural research. FAR's research tackles several food and agricultural challenges, including climate change. As you all likely know, agriculture contributes roughly 13% of global greenhouse gas emissions when you're talking about the primary production of crops and animals for food. But the sector also has the potential to be a powerful climate solution, reducing emissions and even going negative using carbon sequestration. FAR and the World Farmers Organization launched AgMission as a global initiative to advance research, achieve net zero greenhouse gas emissions. This initiative is connecting farmers and scientists to advance collaborative research. Specifically, we're fostering collaborations to develop actionable solutions to urgent challenges while accelerating the adoption of proven practices and technologies on farm. Ultimately, AgMission is about developing and deploying climate-smart practices to unlock agriculture's potential to address climate change. The COP meeting you all are at this week is an important opportunity to amplify how research and collaboration can reduce emissions and increase adaptation globally. This climate meeting must also consider how to fund these efforts at a global scale. AgMission is leveraging FAR funds, which are provided by the US government, and matching those with private sector stakeholders to fund research that can ensure high yields of critical staple crops for years to come. The initiative is an example of leveraging investment and using that to conduct critically needed research. So we're proud here to showcase AgMission's latest research grants that have been announced. AgMission is also one of the original Aim for Climate Innovation sprints. I'm joined actually today, two of the panelists you'll hear from today are participating in a project that also links up with another Aim for Climate Innovation sprint led by Fontegro on carbon sequestration in Latin America and the Caribbean. Today, I'm joined by some key stakeholders in AgMission. Chris Johnson here is the Director of Agriculture for the Nature Conservancy's North America region. He leads an interdisciplinary team of science, policy, and agriculture experts in a collaborative approach to help farmers and ranchers meet the growing demand for food production while protecting critical lands and waters for people and nature. The Nature Conservancy is an AgMission founding partner, so Chris works with FAR and our other partners on our executive committee to determine what research and efforts are critical to advancing the mission of AgMission. I'm also joined by two scientists who are part of a large program that's just been announced on soil carbon farming as a climate solution. Dr. Alan Franzlubers is co-director of the Southeast Regional Climate Hub here in the US and a research ecologist at the US Department of Agriculture's Agricultural Research Service. His research focuses on soil ecology and management for development of more sustainable agricultural systems. I'm also joined by Dr. Umakant Mishra, principal member of technical staff at Sandia National Laboratories in Livermore, California, where he studies impacts of land use and climate change on the soil system, using field observations, remote sensing, and environmental data sets, as well as geospatial and process-based modeling to conduct studies at local, regional, and global scales. So I'm really delighted that all of you could join us today, this morning, and really looking forward to hearing from you and having a great discussion. So with that, I'm going to hand it over first to Chris to give us a little bit of his thoughts on the program of AgMission and the Nature Conservancy's interest and role. So.
Thanks, Allison, and thanks, FAR, for convening this. So as Allison mentioned, I'm Chris Johnson, and I work at the Nature Conservancy. And most of you probably know about the Nature Conservancy, but just briefly, our mission is really fundamentally simple and ambitious. We're trying to do what we can to conserve the lands and waters on which all life depends. And so it's pretty easy to see that immediate connection with agriculture as being essential, obviously, to support humanity and the food and fiber that we need, but also to, sustain the ecosystems and the water and the coastal habitats and the climate that, of course, agriculture and productive, profitable agriculture is dependent upon. And so that's really why agriculture is central to our mission. I mean, here in the United States, the program that I help lead, agricultural lands, grazing lands, grasslands, croplands, occupy about 1 billion acres in the continental US. And so this is a huge amount of our land area with a huge potential impact on our environment, and also a huge potential to provide benefits, to provide climate mitigation benefits, to provide improved management in ways that can improve our waterways, our lakes, our rivers, our coastal areas, and provide habitat for wildlife. And so for all of those reasons, we're intensely focused on doing what we can to help scale up the adoption of regenerative practices, climate smart practices. These include things like cover crops, conservation tillage, extended rotations. They also include kind of larger ways to think about managing the landscape better with targeted, use of edge of field practices, agroforestry, practices like that together as part of kind of a whole farm and whole ranch management approach can deliver really profitable and productive agriculture, but also a suite of, these benefits, these ecosystem service benefits that are also just critical coming from our ag lands. In the US, our agriculture is particularly efficient. And so our greenhouse gas emissions profile, from the agricultural sector, from food production, is lower, but still there are huge opportunities for improvements in management of agricultural lands, both croplands and grazing lands, to deliver meaningful climate benefits. A colleague of mine at the Nature Conservancy a few years ago published a paper on the natural climate solutions that are possible in the United States. And, just to give a quick example, 2 practices, one in croplands and one in grazing lands, avoiding grassland conversion and planting cover crops in a pretty widespread way in croplands. These 2 practices alone, they estimated could deliver 200 million metric tons of CO2 equivalent benefit annually. Estimated, but still, it's an enormous potential that translates to a huge climate mitigation wedge available for our country if we can invest in a meaningful way in making this transition. And so part of that investment, of course, is around science, and it's around research, it's around data development, because we need to understand the costs, the benefits, the barriers to adoption that present themselves to farmers and ranchers all across the country. We need to understand over what period of time might we expect a certain suite of practice changes to provide benefits for farmers? What's that transition cost look like? What are the potential trade-offs between adopting one practice or another practice? So there's a whole host of sort of knowledge gaps that we need to fill, and fill quickly, and we need to do so in a way that supports farmers and ranchers and helps them find easy pathways to adopt these practices, and also provides incentives, whether it's public incentives or private incentives, that better connects consumers and the public and society at large, and the investments that we're all making with the incentives on the farm and the ranch to actually make those changes, from acre to acre and from farm field to farm field. And so that's why, the Nature Conservancy was really excited about the opportunity to be part of AgMission, because we see this investment in research, this investment in data, in shareable, publicly available, translatable data as being foundational for making this progress that we all want to make related to climate smart agricultural practice adoption. We're particularly excited in several different projects that are just getting up off the ground. I'll give a few examples. We're really interested in better understanding sort of the social science behind practice adoption. We've noticed that in many cases, cover crops, for example, might be adopted in certain places, but then after a couple of years, they're disadopted. They're removed from the landscape and they are shifted to somewhere else. And we're trying to understand the social factors behind that. Is it a technical issue? Is it simply a financial issue when a cost share payment ends? So we're doing some research in collaboration with Purdue University and others to try to understand, what makes practices more sticky and more durable in certain places than others, and how can we do a better job to create those enabling conditions. So that's an example of one project that we're working on together with AgMission and with other partners. Another example is increasing investment in remote sensing and data development to assess at really, really large scales the progress of adoption of practices in both croplands and in grazing and grasslands. And then we are also working in sustainable grazing, regenerative grazing lands, and working to figure out how can technology support improved integrated ranch management planning, and in turn help support improved ranch management, which can lead to avoiding conversion, keeping grass in grass, keeping that carbon in the ground, and also provide a range of benefits in terms of, forage productivity, profitability, and habitat benefits as well. So those are a few different examples of the research that top of mind I'm really excited about with AgMission. But in general, I think, the next 5 years, the investment, the collaboration, the public-private partnership that AgMission brings are really just going to be critical for advancing all of us in helping make this change to climate smart agriculture. So thanks again, Allison and Far, for the time to offer some thoughts.
Great, thank you, Chris. I appreciate that. We're going to continue on with the other panelists before we get to questions, but please go ahead and start thinking of the questions you have for Chris. Now I'm going to hand it over to Dr. Franz Lubers to talk a little bit about a project he's working on, a program under AgMission that was just announced in the last couple of months, is soil carbon farming as a climate solution, led out of the Ohio State University, but with a wide range of partners. So Dr. Franz Lubers, please.
Thank you, Allison. Good morning, everyone. Yes, it's a pleasure to be here with you. I'm speaking on behalf of Dr. Ratan Lal at the Ohio State University and the program that he has developed with partners. The project that we have is called Enhanced Soil Carbon Farming as a Climate Solution. We've given it a name of Carbon Farm. And things are developing quickly, but we are just getting started. We've actually been looking at getting some samples already. So we are a research-based project where we are fully engaged in the scientific process of understanding what is management that farmers do and how they actually change the soil. So soil carbon is a phenomenon that is important, not only for climate change, but for agriculture itself. If we have low soil organic carbon, farmers actually have harder times producing their products. And so it's important for farmers to understand and to appreciate the value of carbon just on its own. And we relate that to soil health. Soil health is the ability of soil to actually function, to provide the services that are needed for agriculture to prosper. Okay, so we're interested in this project of looking at carbon on private farms. There's a lot of research that has been conducted and modeling efforts are associated with that on research stations around the country and around the world. And this is all very valuable. And yet, farmers have a little bit different operation. They have management practices that they may not continue with, say, no tillage every year throughout the lifetime of the farm. Whereas on a research experiment, that's what we study. We study consistency of the practice, and that's important. In the other aspect is that research station experimentation for long term is actually difficult to conduct over years. It's expensive, it's resource intensive. If we partner with farmers, they actually are implementing practices and we can follow those over time. Or we can also consider that it's a chronosequence in that maybe some are just adopting some practices. And others have been doing it for 25 years and sometimes even longer. And so we have intergenerational aspects of it. So we're really excited about getting data from farms so that we can understand it, feed it into some modeling effort, and to understand how it relates to soil health building practices. So we're working with cropland farmers as well as grassland farmers. And so many of the practices that Chris has already mentioned, such as no tillage, cover cropping, organic amendments, whether that be from livestock or biosolids or industrial products as well. Crop rotation, grazing management. Grazing management is important, not only about the the stock density, but the stock method, whether it's rotation or continuous, and really focusing in on the actual productivity and how it relates to the environment and carbon accumulation. We intend to sample soils down to 60 centimeters in at least 3 different increments. And so we're focusing on what happens near the surface. Surface soil organic carbon is extremely important. This is what farmers manage, and this is what that will be realized in their lifetimes. Well, we need to understand what happens with depth, but in fact, what happens with depth may be maybe a minor component. It may be longer lived, but that's something that we'll have to investigate and find out more about. But the idea is that we look at the profile distribution, and this is an important aspect, and we're being able to characterize on farms what their current condition is. And if we know that there's significant accumulation near the surface, we can actually understand that those types of management systems will be more beneficial. All right, well, we're as I mentioned, we're feeding into the biogeochemical models that Umakant will talk about, but we have variations in the ecoregions of where these investigators are. So Dr. Lal has assembled a team of researchers from Ohio, Michigan State, Utah State, Kansas State, the U.S. Geological Survey, Sandia National Lab, the USDA Agricultural Research Service, and international partners such as the National Agricultural Research Institute in Uruguay. And then, of course, we have our industry partners, and I have a list of them, but it's maybe Allison, you can touch on them and knowing more about them. But it's important that we have these industry partners because we want to be able to share our data, not the primary data, but the results of the investigation, so that we can actually get a better understanding throughout the whole agricultural community. Might I also state that on the soil health aspects, Dr. Lal is very interested, I'm very interested, and others on our team are very interested in how carbon actually contributes to the soil health. And so we'll be looking at various measures of aggregate stability, of nitrogen mineralization, of particulate organic matter. All of these things are important to get a fuller understanding of how management on farms is going to contribute to carbon sequestration and the health of our soils. So these data are important on farms. And again, we'll be attempting to integrate that into some biogeochemical models. So the prediction aspect will be important as well. Thank you, Allison, for the time, and I'll be happy to discuss more with you. Thank you.
No, that's great. Thank you so much. Yeah, it is a key component of that project. You're taking the research from those research plots onto working farms and working with farmers who are interested in the practices, have been doing them, and actually taking them to that scale and studying, doing the rigorous scientific methodology at that scale. But as you mentioned, that's going to feed into a lot of modeling, which is my own background, and love to see such a robust modeling effort. So Dr. Mishra, can you talk a little bit about that work you'll be doing?
Thank you so much, Alishan, and I appreciate the opportunity to talk about the kind of research that we are planning in this project. So I'm a computational soil scientist, and we have a team at Sandia National Lab which does a different kind of modeling, and we are basically interested in predicting the impacts of land use and climate change on soil properties and soil functions. And we conduct our studies as a variety of scales that ranges from plot scale to regional scale to global scales. And in this project, which we are excited to be part of, we have 2 clear objectives that will help to meet overall the project's objective. The first one is we will take the field observations that will be collected by our project partners, and we will try to extrapolate it to the croplands of the US and the grasslands of US. And another objective is we will try to quantify the impact of future climate extremes on the soil carbon and carbon sequestration process, and how it relates to other services that soil provides. And in order to do that, we have proposed to use an approach. It's called ensemble agroecosystem modeling. And for that, we will be using 3 models: ECOSYS, DESCENT, and DNDC. And through our other projects, we have created a framework to run these agro-ecosystem models across the continental United States at 4-kilometer grade. So we have collected all the data that is needed to run these models. And after generating the modeled outputs from 3 models, we'll use the average values as the value for while quantifying the impacts of different agriculture management practices in the continental United States. And after creating these high resolution maps by using the ensemble modeling, our another job in this project is to quantify the impacts of climate extremes in future. And for that, we have downscaled, bias corrected, and quantified the frequency, severity, and extent of climate extremes in the continental United States already through our other project supports. And we are very excited that we will use those downscaled climate data to feed into this project to look at the impact, how they will impact the soil carbon sequestration and other ecosystem services that carbon provides to soils. And the most inciting or the problem that I am very interested to look at is how the change in carbon concentration in soils will impact or will help to buffer the future climate extremes. For example, if in absence of recommended management practices, what would be the impact to continental US soils? And if we adopt the different recommended management practices, how much climate extremes we can buffer through the recommended management practices that farmers are doing or will be conducting under this project. So these are the exciting ideas that we are trying to look at in this project, and we are very happy that we have an opportunity to contribute in this novel project, what I would say. And I'll be very pleased to take any questions that falls on my domain of the project. Thank you.
Great. Wonderful. Thank you all. We are going to open it up in a minute for questions. So please go ahead and start putting those into the Q&A, but I'll take the moderator's prerogative to ask a question ahead of time. It's something that's sort of been touched on by you all up to this point. And I think kind of comes to the core of the purpose of AgMission and a challenge that others in this space face, working on understanding how agriculture can be part of the solution to climate change. And that is that we have a lot of great science that demonstrates the benefits of certain practices and the sort of farm level economics that shows that things like cover crops and other, can pay off for the farmer's balance sheet in certain circumstances. So we have a lot of great work there. But we have seen very slow adoption of some of these practices. And to Chris's point earlier, even when they are adopted or tried out for a few years, sometimes you're seeing that they're abandoned after a little bit of time. And so really, I think we face this challenge of if we have a good solid base of knowledge of the practices we should start trying. I think there's still lots of research that needs to be done, obviously. But the key challenge that I think about is, okay, then how do we actually turn that into action and turn that into creating those enabling conditions for farmers to adopt these practices? And it occurred to me, Dr. Franz-Lieber, as you were speaking, that perhaps that on-farm research is a way to sort of draw farmers into participating in the research. And I thought I'd ask you, but also the other panelists, what you think about, when you're working with farmers who are experimenting with these things on their fields, what is most motivating to them in terms of making a change in a practice, which is not a minor thing for a farmer. It can be a lot to ask. So is participating in on-farm research something that motivates farmers to make a change?
Great. Thanks for the question, Allison. That's a very interesting and very attractive question, I think, for agricultural, because extension and research go together. Research conducted on farms can be highly valuable. Some farmers are interested in conducting conducting that research on their farm because they want to understand what goes on their farm. They want to gain the expertise that these researchers will come to their farm and provide them with answers to their questions, their immediate questions, but also future questions. So many of them are very willing to collaborate with researchers. I think that, and I conduct on-farm research in other parts of my program. And I think what motivates them is to actually increase their profitability. If they can be shown that say, avoiding some inputs and still making a greater profit means that they're likely to choose that. But they need to have a research backing so that they don't make mistakes, so that they all of a sudden start losing profitability and productivity. Productivity may go down sometimes with reduced inputs, but that doesn't mean that profitability goes down. And so they're willing to make changes that are profitable. And in a small sense, when productivity goes down slightly, it's absorbed by the rest of the community. So it's not an issue that they're facing. The other thing is that many farmers are actually motivated by the environment. They understand the loss of biodiversity that's out there, and they want to do something to change it. Particularly our grassland-based farmers, the livestock-based farmers where they have pasture, they are very interested in biodiversity and making sure that their landscape is something that their children can enjoy for the next generations. And so it's both the economics and the environment that are important for them.
Okay, thank you. Chris, does that all sound true to your experience there at the Nature Conservancy? I know you do a lot of work collaboratively with producers.
Yeah, absolutely. I was just thinking, I was in Central Illinois yesterday and had lunch with John and Kathy Franklin, and their farm, the Franklin Research and Demonstration Farm, has been working with the Nature Conservancy, with the University of Illinois, Illinois State, Soil and Water Conservation Districts, the DNR, a whole host of partners for probably 15 years or so. And they've just been actively engaged in learning and testing and collecting data and really kind of proving out the benefits and the outcomes from these practices, working hand in hand with, the conservation districts or the Nature Conservancy or others who are then going to turn around and have conversations with other farmers about the benefits and the evidence that is accumulated over this, incredible period of time on this one farm. And it's powerful when that demonstration farm is, in the same county, in the same part of the state, in the same types of soils, in the same climate zone as another farmer. It's obviously not as helpful when you're talking to someone in Illinois about research done in New York or Florida or something. And so I think that idea of a network of kind of living laboratories that are connected with farmers, connected with commodity organizations, with agricultural retail. I mean, there's real power in that building and sharing of information and being able to see and sort of touch firsthand that lived experience. And I think we're trying to do all of that, and then also find ways to connect that with policy, and how do we actually sort of change the ways in which cost share or technical assistance are provided that can better support farmers to overcome barriers and to try new things and to take on some risk in shifting practices. Or how do we link that with companies that want to see different corporate sustainability outcomes come from their supply chain. So we try to kind of think of it all in a really vertically integrated way about, from the ground on up into sort of the public and private partnerships that can enable changes at really big scales.
Great. Thank you. And I also would turn this one to Dr. Mishra, because I think it's really interesting and fascinating to do the type of forecasting modeling that you're planning to do, or you're going to look at what are the potential impacts of climate extremes using the data from the field research that's been done, and look at that. And is that something that you think will provide evidence, motivation, and so on to those people developing policies and programs for farmers to help them understand, here's the types of impacts we're looking at down the line, and here's how we need to be thinking about our agricultural policies or our markets or things like that. Is that one of the objectives for your work? And can you speak to any of the use of the modeling that you'll be doing?
Thank you, Alison. Yeah. So the answer is both, or all of the above, because our idea is to want to help farmers and also to create understanding, the scientific understanding that we don't know about. So we will be creating new knowledge through this modeling exercise, which will be helpful to farmers and policymakers as well. But when a policy is put into a place, in my knowledge, it's usually done either at a national scale or at a global scale. And that's where these models become useful, so that we can take the different observations that our OPIs or project partners will be collecting at different farm scales and try to upscale that information to the national scale. And for the climate extreme part, I think this kind of work still need to be done. And our idea is we'll be able to quantify the impact of future climate extremes, which are projected under coupled model intercomparison project phase 6 of IPCC. We have downscaled that data, and then we will now use how they will impact the agricultural productivity and soil carbon sequestration of continental United States. So the answer to your question, as I earlier said, it's both. So our intention is to, one, create new knowledge, and second, provide that information to policymakers, which might help their decision.
Great, thank you. Yes, excited. It'll be very exciting to see all of that work come together over the next few years. We are starting to see a couple of questions come through in the chat, so I'll just read them out. If you would like to, I guess, ask your question in person, you can indicate that and we can unmute you. But this first question is, Dr. Franz-Liebers, what do your models show about the time frame of soil carbon increase after the implementation of regenerative practices? Does it take 1 year, 3 years, or more? So what can you speak to that?
Okay, thanks for the question. Well, I'm not a modeler. Umakant is the modeler on our team, and he can answer the question with the modeling answer. But I would have to say that based on our empirical data, that we would say that generally a practice implemented for 10 to 25 years is something that then can reach some sort of steady state. But it really depends on the type of practice and the environment. And this is not a fuzzy answer. It's just that the environment does make a difference as to how durable that carbon will stay in the soil, but also the extent of the practice. If the practice is actually just modifying carbon inputs a little bit, then we can't expect that the carbon output on the soil organic carbon can change dramatically. But in general, practices are temporary, and farmers then could actually change their practice, and that means that the carbon outcome in the soil could change as well. And this is just a part of nature. We know that on the planet, carbon cycles through respiration. It's one of the largest fluxes, or it is the largest flux on the global sphere. So we have to realize that carbon in soil is always in flux. It is even the most the thousands of years of carbon, that carbon is also in flux, although it's at a small flux. My point being that we should just not say that it's just going to be durable. If you get it into the soil, then it's durable. It does go under flux, but if we have a steady state management, then we can expect steady state carbon accumulation.
Thank you. Yes.
Alicia, maybe I'd like to take the second question here. Alan did a great job.
Credits? Yes.
Yeah. So, okay. So thank you very much, Suzanne, for your very nice questions. You had 2 questions, basically. How, what is the time frame that you can maybe quantify the soil carbon change, which Alan answered. And the second question you had was how much carbon we can store in a soil. Again, the answer is it will be soil and site specific. And in my understanding of soil carbon dynamics, it's a dynamic question. So under changing climate and land use, we don't think it will be one value or X amount of carbon that could be stored into a soil and it stay there. In my understanding, this is a dynamic question and it will change throughout the time frame. And that is why we are interested to conduct our modeling studies in quantifying that, because we know that there is a lot of changes being made into the soil profile. And as climate changes, it alters all the soil forming factors that controls the soil carbon accumulation at a place. And because of that, in my thinking, this how much carbon that can be stored into a soil is a dynamic property.
Thank you. And I'm not surprised we got a question about the markets here. And that is, that raises also the timeline question, I think, here in that second one about how long, how much carbon could be stored and stay on farm. And to me, there's also that question, and for how long, like how long will it stay there? And you both raised a really good point that, you know, if you keep the management the same, the carbon's going to stay the same. So even if you transition to a new state of management, the carbon will kind of equilibrate over time, right, to that new state and stay there. So it's not a continuous annual sequestration or anything like that. It's a little bit different than other types of carbon storage. So I don't know. I mean, might throw this to Chris in the sense of talking a little bit about the carbon market situation as it currently stands, and how markets are dealing with some of this complexity in the science and the complexity of soil dynamics, and that type of issue. If you have any thoughts there.
Oh, the easy question for me.
The easy one, yeah.
Yeah, no, I mean, this is really challenging, and it's kind of been. You know, it's been what a lot of us have been looking for a while, which is trying to kind of close the loop on the incentives and the externalities, as economists would say, that, you know, we know that there are these other benefits from well-managed, you know, crop systems and grazing systems. They could be carbon sequestration, they could be reduced emissions, they could be water quality benefits or habitat benefits. And as of yet, our supply chains, our market economy doesn't account for that. And so we don't have the ability to incentivize management that generates other benefits that we all would like to see, but which are not kind of priced into the commodities. So we all know that. And that's where this push for carbon markets, you know, carbon claims, water claims is coming from. And, you know, as people have been saying now for a couple of years, we're still in the early stages of that. Because I think, as you know, as the other panelists could speak to, you know, much more knowledgeably than I can, there's a limited potential to add carbon in some systems in a durable way. And that becomes challenging when you're talking about annual management decisions. And, you know, so how much does that carbon need to be worth if you're able to accumulate, you know, 1/4 of a ton, you know, over, you know, interannually under some sort of suite of management practices? Well, in order to pay for that practice, that price needs to be pretty high if we're expecting that price signal alone to incentivize the change in practice. And so that's where I think we really need to think a little bit more holistically, and we need to think about, you know, stacking benefits from other you know, other ways in which the practice change will provide benefits. It could be water, it could be, you know, habitat, it could be on-farm kind of resilience and productivity benefits over time. So, you know, I think we're all excited for a little bit of this, you know, kind of Wild West in the carbon market space to settle down. I'm much more interested in, you know, the sort of internal supply chain sort of scope 3 approach to thinking about GHG reductions and carbon sequestration in agricultural systems. I get very concerned about the notion of offsets in the agricultural space, especially in crop systems, where, you know, the offset, the registry requirements around permanence and is really challenging to think about in that kind of annual management cycle that a lot of you know, crop systems are sort of confronting. So I really think there's strong potential to kind of stack a suite of supply chain actors that are, you know, buying commodities from a supply chain, to stack all of their kind of investments around getting sustainability outcomes from their supply chain, and to make better connections between those companies, their consumers, their customers, and the farmer. I think that can deliver incentives that can meaningfully support farmers in a transition. But it's by no means a silver bullet, and there's you know, it's absolutely essential that we be rigorous in quantifying, monitoring, verifying these changes, so that we're not, you know, claiming kind of climate outcomes that are ephemeral or, you know, not substantial. So Anyway, it's a fine line to walk, but I do think there's a lot of potential here. We just have to keep working, keep testing, keep learning.
Yeah, great, thank you. Yeah, I think it's one thing to talk about taking on some of these practices to improve the environment and enhance resiliency and things like that, but actually then measuring the greenhouse gas impact or the carbon uptake to a really rigorous level is a big challenge, and that's certainly one of the things that the Ohio State University project will be looking into. We've had another question come in, and I'll kind of see who wants to answer this one. This is from Julia Stellari, who heard earlier in the conversation the idea of reducing inputs. Why would we choose for lower inputs as opposed to higher input use efficiency? Technical efficiency of farmers is still in many cases low, and yield potential in many systems is well above what the farming system produces as an output. So from a greenhouse gas and environmental impact standpoint, would it be better to aim for greater efficiency as opposed to lower input systems? This might be a case where there's differences based on US versus international. I don't know if anybody has any thoughts on this question. Great question.
Well, Allison, I would love to take the first crack at it. Thanks for the question, Julia. Yes, the reason that I mentioned reducing inputs, I was coming from perhaps a U.S. Perspective there, but yes, obviously around the world we come from both sides of the optimization that occurs, and resource efficiency should be our goal. Obviously, yes, we need to be efficient in the way we utilize our resources, and so there are going to be some situations where inputs are needed to be able to raise productivity, to raise the livelihood condition of people in various countries and various landscapes, because landscapes can be very challenging. Resource input is needed in some cases, but in the United States, we have an example where nitrogen fertilizer is used quite extensively for decades already. And I would say that's because of the cost of the fertilizer. And so we're an affluent country, and the farmers have been accustomed to that. Generations have been accustomed to that. And we see the opportunity to reduce nitrogen inputs, not dramatically, but substantially, where greenhouse gas emission could be reduced, water quality could be improved, and productivity and profitability could be increased. We don't see that productivity will decline substantially, even with a reduced input. So it depends on the situation. This example that I'm giving you through the United States, that by reducing nitrogen fertilizer input, we can actually increase productivity, profitability, and improve environmental sustainability because of the history that has occurred. Whereas in another country where resources have been limited and there's an opportunity to get greater plant cover, to increase the dynamic on the land where it's a more productive system, inputs will be needed. And we want to have those inputs lead to a greater resource efficiency. Whenever we add inputs, our greatest benefit, oftentimes, if it's a nutrient-related input, is from the first increment of that input. And when we have more and more increments of that input, we get less efficient. And so by getting down to the optimal level, that's where we want to be. So thanks for that question.
Thank you. Anyone else have an interest in responding to that? All right.
I don't think I'll add anything. I would just agree with Alan and also with the question that, you know, we really talk about kind of optimal nutrient management, and with the notion that, you know, even in the US, in some places, you know, optimal nutrient management might be an increase dependent upon the crop and the soils and the conditions. But really, it's looking towards outcomes. It's looking towards nutrient use efficiency. It's looking towards sort of leaching and loss of nutrients depending upon the time it's applied, the source, and that sort of thing. So it's really trying to optimize the application and the use of nutrients in a way that minimizes loss to the environment and maximizes uptake to the crop. But yes, the US situation is obviously really different than a lot of places in the developing world.
Yeah, Alison, maybe I would like to add on this. So the idea is that once you increase the carbon concentration, organic carbon concentration into the soil, obviously that will lead to also increase in soil nitrogen concentration. And the idea is if the carbon sequestration happens into the soil, maybe you will need less nitrogen fertilizers to produce the same level of crop yield. That's what we are aiming at, to enhancing the nutrient use efficiency through carbon sequestration. Thank you.
Yes, great point. Yeah, there's that added benefit of higher carbon, higher organic carbon in soils of nutrient efficiency. So I'll just ask sort of one final question, given many of our attendees are at COP this week and talking about all sorts of solutions to the climate crisis. And, you know, there obviously agriculture is a part of that solution, has part of those emissions. But can you just like maybe give a few thoughts on why it is important for agriculture to be part of the solution to climate change? What is agriculture's role here, given that we have so many other sectors, of course, of the economy that are also working to decarbonize energy and transport and so on and so forth. So what is really the unique situation for agriculture, and why should it be sort of front and center in people's minds this week? Give you a curveball if anyone wants to opine on that for a few minutes.
Allison, I could take the question first and try to answer at that. Food, feed, and fiber and fuel that was from agriculture are extremely important. We all depend on them. So we need agriculture in our environment. And so and our environment can suffer, or it can benefit from that activity. So we are in agricultural research, we're trying to be more efficient. We're trying to be more sensitive to the environment that we live in. And it is part of the solution, because agriculture is required for us to survive. And so, and essential to that is the soil. And those of us in the soil health space, that we want to improve our soil so that they can continue to function for generations to come.
Great, thank you.
Yeah, thank you. I would like to add what Alan just said. So if you look at agriculture at a global scale, historically, it has been a source of greenhouse gas emissions. And what we are trying to do, or many scientists or practitioners are trying to do, is to make it a carbon negative, or if possible, sink of atmospheric carbon. And that's we are trying to do through these recommended management practices, which if are applied on global soils to the extent possible, it will act as a carbon sink. So that's why agriculture should not be considered only as a source of greenhouse gas emissions, but it can be also a part of solution. And that's why researches are being conducted on the carbon sequestration capacity of soils and how they might evolve under changing climate. And we think these kind of activities will help to achieve that goal. Thank you.
Great, thank you. Thank you both.
No, I completely agree with Umakant and Alan. And I would just add also that, you know, we really think about this, and I mentioned this kind of in my opening comments about the multiple benefits. Agriculture occupies, you know, such an enormous amount of land area, both in the US and around the world. And that land area is not static, right? We are seeing continued, even after, you know, more than a century of intensive agriculture in the Midwest, we're still seeing conversion of native grasslands and perennial grasslands to row crop agriculture. And when we do that, we lose an incredible amount of carbon, an embedded carbon that's in the soil and in that perennial biomass. And of course, we also lose habitat. Grasslands are, you know, the least protected habitat ecosystem on the planet. And so anything that we can do, for example, to freeze the footprint of agriculture and stop the continued conversion of perennial systems, whether it's, you know, the Great Plains, or whether it's the Cerrado in Brazil or the Amazon or other places around the world, anything that we can do to maximize the productivity and the profitability of the agricultural systems that we're using right now to prevent additional conversion will have tremendous benefits in terms of avoiding loss of carbon into the atmosphere, maintaining habitat, protecting water, and, you know, supporting life in a variety of other ways. So I think a lot about those kind of interdependencies between the agricultural lands that we use and how to manage that going forward. And, you know, even the current lands that we have, improving management of that will have tremendous benefits for our waterways, you know, for drinking water supply sources here in the US and around the world, for coastal fisheries, for recreation opportunities, for a variety of other things. So that interdependency of these systems on both habitat, biodiversity, water, climate makes improving our management of them essential, because as Alan said, we all have to eat. We're all wearing clothes. We need these systems to be productive and efficient, and not just now, but going forward into the future, into a climate stressed future where productivity is going to be challenged. So it's really, really essential that we do our utmost to improve the management and the resiliency of these systems.
Great. Great. I certainly agree with that. Well, thank you all so much for your time today. For those of you listening, if you'd like to learn more about our program, there's two websites, agmission.org and foundationfar.org. Please feel free to go check out what we're doing. We are still building public-private partnerships under the AgMission umbrella, so we welcome people outreach if you have interest in supporting research on climate smart solutions. That's what we're working on day in and day out with AgMission. So happy to have shared this today and to have had these three great panelists to share their thoughts and their work with us. And with that, I'll say thank you all, and appreciate everybody attending, and go have a wonderful afternoon there in Egypt. So thank you. Thank you all.
Thank you.